if you're interested in learning more about building serverless applications on AWS, you're definitely in the right place. In the course of the day, we're going to get progressively deeper with the technical sessions that we're going to run. So the first session is going to be a quick recap of recent announcements associated with running serverless apps on AWS, which I'll deliver myself. I'll introduce myself in a second and talk a little bit more about what we're going to cover. Then we're going to have Danilo Pocha, who's sitting up front with me here. Actually, one of the first authors in the serverless domain. Danilo is the author of a book called AWS Lambda in Action, which was published over a year ago now on Manning, which is really one of the first educational books about how you can build applications using this new programming model, using this new delivery paradigm. So I've got a real expert in the room to talk to you a little bit about the developer experience for serverless apps. And he's going to return at the end of the day and talk about step functions, which is an adjacent service that we have that enables customers to build more complex multi-function applications that have branching logic, state control, and other advanced features within them. So you'll have that at the end of the day. That's going to be a 400-level session. And then those will sort of bookend 2 more sessions with Adrian Hornsby. Adrian is a technical evangelist with AWS up here in the Nordics, and we'll be talking about patterns in architecture for serverless apps, and we'll also be talking about a new AWS feature for an existing AWS service, a new feature called DynamoDB Global Tables, which is a mechanism for building globally distributed state stores that you might put behind your serverless applications to assure good performance for customers that are globally distributed. Again, that's going to be a 400-level talk. So as we go later in the day, we'll get progressively deeper with the content. I hope you'll stick with us and listen to the whole track if you're interested in learning more about this domain area. So, my name is Ian Massingham. I lead technology and developer evangelism for AWS worldwide, so they gave me the less technical session, presumably because I have manager in my job title. I'm getting down ranked now. As I get more senior, I get less trusted with talking about technical topics. It's like the CTO, you know, the amount of code you write is inversely proportional to the level of seniority that you have. The more senior you get, the more your team look at you and think, stay away from the keyboard, stay away from the keyboard. So I guess that's happening to me as well. I was going to take you through some of the new things that we have recently announced in this topic area, in the area of serverless application development, and hopefully give you an insight into how this is helping customers use AWS Lambda and these other associated services for a broader range of different application types, you know, to satisfy a broader range of different use cases. Just wind back to when we first announced AWS Lambda. And Danilo and I were both in the keynote at AWS reInvent when we announced this service. I think it was a really interesting launch for AWS. We have a few of these where we announce new services and customers kind of know they're going to be significant, but you can't quite appreciate quite how significant they're going to be. You know, quite how different a new service will make the way in which developers, you know, probably one of the most well-known and heavily used AWS services. Who could have predicted at that point quite what a big impact it would have on the way in which, not only the way in which developers work, but the way in which the IT industry works at large? It's actually been a really big change over the course of the last 11 years. You probably look back now and you know, here's a question for you. If you're building a new application or service or a new product, who here would default to buying servers and buying equipment to do that? Who would actually put a rack of equipment into a data center somewhere and use that to deliver an app or service today? And remember that just 11 years ago, you had no other option. That was the only way to work, right? It was the only way to build apps. Every app you built needed an infrastructure stack that went with it. That is a really, really substantial change in the way in which we work as professionals in the domain in which we work, right? It's probably one of the biggest changes in IT that's ever happened. The idea that the ownership of infrastructure is completely disconnected from the software that we write. That's a big, big deal, right? And I think if you look back 10 years from now at AWS Lambda and the other services that sit around it, and remember, serverless is way more than just compute. Serverless is the whole delivery model for not running low-level infrastructure components and not managing low-level infrastructure components through their lifetime. It's all about entering the stack at the highest possible level of abstraction and writing the absolute minimum amount of code that is required to get the job done. right? That's what we're really talking about when we talk about serverless. I bet you that in 10 years, you'll look back on AWS Lambda and the rise of serverless applications, and you'll think the change that we saw with EC2 and the rise of cloud computing was minor in comparison to the change that we've seen over the last 10 years with the introduction of this new programming model and this new way of building applications. I think it'll be that significant when you look back on it. And you're sort of 2.5 to 3 years in to substantial use. So you're still in the pioneer group. You're still the first people that are learning how to build applications in this new way. The people in this room in the Nordics are likely to be those that are first to seize this new model. And actually, it can really transform the impact that you have in your careers and really transform the impact that you have in the sectors and industries in which you work as well. So I know it's kind of a big opening, but I don't believe it's possible to overstate how important this change is going to be as we look back on it in a few years' time. It's a big, big deal. Okay, and the reason it's a big deal is this. Like I just said, writing the minimum amount of code to get the job done and performing the absolute minimum amount of heavy lifting. At AWS, you hear us trot this out quite a lot. Undifferentiated heavy lifting. Activities that you have to focus on but don't really add to your mission, don't really add to you achieving the goals that you have. Our view is that you should move as much of that stuff as possible down into the platform and let the features of the service that you build on top of carry most of that heavy lifting for you. Okay. In the case of serverless, that means no operating system. If we're talking about compute, each time I access one of these low-level or high-level primitives upon which I have built some aspect of my service, just interacting with that service through this high-level abstraction interface, and I don't have to think about the underlying technology upon which it sits, even where it runs, okay, whether or not the underlying infrastructure is patched to the appropriate level, whether or not there are going to be enough copies of my function or enough capacity to support the level of throughput that I need on my database. All of those activities are pushed down into the platform and carried automatically by the service. So no server management, flexible scaling within reason, with a few dials and sliders, practically unlimited, practically infinite scaling actually. So there's no upper limit on how much capacity you can use as long as you move those limits upwards. And we'll talk a little bit later about why you might want to artificially move those limits downwards as well, because there are good reasons for that. We introduced some new features quite recently that give you a greater degree of control over scaling, both downwards as well as upwards. Upwards has always been there, but enabling you to control scaling with fine levels of granularity. Quite an important feature. High availability. So you'll know here in the Nordics that we are building a region here in the Greater Stockholm area, which is going to have 3 availability zones at launch, which means at least 3 physical data centers. In practice, there'll be more than that, but we present 3 physical data centers to customers in the form of logical availability zones that you can build on top of. If you use EC2 and some of our other services, you'll know all about these AZs as a mechanism for achieving availability goals and targets that you might have. With Lambda, those things are still there. With serverless, those things are still there. It's just we use them to deliver an availability goal to you. You don't actually have to think about how you distribute your app or distribute your database, your serverless database, across those availability zones. We do that, so you automatically benefit from high availability. And if we have a failure, well, if you've got functions that are in flight when we have the failure, those functions might fail. So you need retry logic in your apps, but the next time you come to launch a function, that will still happen. It will just happen in an availability zone that's left, one of the ones that is still accessible or still functional. So you don't have to manage availability. You don't have to think about recovery actions. And then lastly, on cost efficiency. Again, we've made some changes to EC2 quite recently that move it a little bit further towards serverless, particularly in the Linux area, where towards the latter end of 2017 we introduced per second billing, which I'm sure a lot of you will know about. So you can run Linux machines on AWS, pay for them by the second with a minimum of a 60-second usage period. So you're going to have at least 1/60th of your hourly charge each time you start an EC2 instance. If you finish it within 60 seconds or on the 60th second, you'll get 60 seconds of charging, and after that you'll increment in individual seconds, 61, 62, 63 and so on. Still at least 600 times larger in terms of billing granularity than a Lambda function, because a Lambda function is billing in the 100 millisecond increment, which is a tenth of a second, of course, okay? And there's no minimum below that 100 millisecond increment. So you've got a tenth of a second minimum billing period. You've also got more granularity in terms of sliding the capacity scale. So you can start down at 128 megabytes of capacity with a proportional amount of CPU and network throughput, and you can uptick that to quite a large number now, which we'll talk about later. You can set that dial, that slider, very accurately depending on what your level of memory footprint or performance requirements are. So not only is it more granular in the sense of timing, it's also more granular in the sense of sizing as well. So you can more accurately size your environment, be very tight on your cost control, or over provision if you need performance, or just to be sure that functions are not going to fail if they have variable memory footprint. So you have a lot of control over capacity usage, but importantly you have zero idle. You don't pay for resources that are not in use, and if there are periods of the day or the week or the month or the year where your functions are just inactive and not used, you have no fixed costs. You have no floor costs that are there just ticking over that you're being charged for. You're only going to get hit with a bill when your functions are actually invoked. Okay. We've also introduced some enhancements to other services. DynamoDB is a good example of this, actually, with auto scaling. So you can now also automatically scale other parts of your serverless architecture outside of just the compute domain, just those computed functions, but also in storage. We're trying to drive towards this ideal of scale up and scale down. And we pre-announced a new service at reInvent last year at the beginning of December, Aurora Serverless, which will provide a relational database model which also has these elastic per second billing characteristics as well. So we're moving many of our other services forward in a way which will help them better align and better support this sort of model, this sort of capacity constrained model this low wastage model where you can only pay for the resources that you use. Okay, so let's just see how the workflow goes for a developer that is building applications in this way, and talk about some of the enhancements that we've made and the way in which some of these new enhancements, new service announcements affect the way in which developers might work with this collection of services that we provide. So this developer's made a promise to his boss to deliver an app with specific functionality. How do we tackle that? Okay, he knows that he wants to build it in a way which is efficient, serverless, without having to run and operate infrastructure. So the first thing that he can do is look for an example of an application which already fulfills the broad use case requirements that he has in mind for this particular application. Okay, knows he needs a serverless web app, wants to host it on an API gateway endpoint, access existing data stored in a DynamoDB table, has some static assets associated with it, JavaScript, CSS, client-side JavaScript that is, CSS, maybe art assets that are required for the look and feel of the application, and he wants to encode business logic as Lambda functions. And we announced something new at AWS reInvent called the Serverless Application Repository. If you are whitelisted for this, it will appear inside the Lambda console when you hit the Create a New Function button, which is of course in the top right of the Lambda console. You'll see an extra tab available to you. These two have been there forever, okay? And actually this really, to some extent, extends the idea of blueprints. Let's just talk about these two first of all. Author from Scratch will drop you into a configuration page where you can either use a WYSIWYG editor to edit your function directly in line in the console, and we'll describe that a little bit more later, or you can choose a blueprint. And a blueprint is just a pre-uploaded package of Lambda function code that we made available in the console that has the function code and dependencies packaged within it for a specific use case. One of the common examples that we started with at day one was imagery sizing. It's still available as a blueprint within the console. Another is Alexa skills. So there are various blueprints for Alexa skills with different functionality available in the Lambda console. If you're getting started Alexa, Amazon Echo programmer, you can use one of those and it will bootstrap a function that has basic functionality for particular types of skills. I believe one of them is the favorite color skill. So you can specify your favorite color and then ask Alexa later on what your favorite color is, and it will remember it using state storage. So these are very, very simple apps. They don't really have dependencies. Okay, they're very, very lightweight single function models. What we're doing with the serverless application repository is extending that, okay, into fully packaged fully functional serverless applications. Okay, and you can search here by typing in this search box characteristics, attributes, functionality that you're looking for. Okay, so there's image conversion might be something that you go for. You could type that, or stateless web apps we've done here, and you'll see a catalog of applications, not functions, a catalog of applications be returned back to you when you do that. Okay, and that will allow you to work through a wizard-based configuration and deployment model for the applications that are packaged up and available inside that serverless application repository. What you're using here is SAM templates, so the serverless application model, which is a further abstraction layer, transformation layer, which is defined using AWS CloudFormation. Okay, so SAM is really a special purpose CloudFormation template that provides simpler abstractions for resources that are commonly used in serverless applications, Lambda functions, API endpoints, and a specific derivative of the DynamoDB table, which is intended for very simple or simpler use cases, let's say. Okay, so you can define all of those within a SAM template, a serverless application model template. So you can see here we have a AWS serverless function resource type defined, and we have this connected to an API gateway with a particular resource type here called /products available with a method, and that's linked to a specific handler within the Lambda function. So we can essentially define and lay out the resources that are required for our application in this templating language. We can execute those directly from the serverless application repository and have them deployed directly into our account as fully functioning serverless applications. Okay. There's going to be a library of apps available inside the serverless application repository for deployment via this process. Also expansion tokens available, so when these are deployed into different customers' accounts, they will be customized, and we use environment variables to do this. So you're going to have environment variables within your Lambda function config that set up the account-specific attributes for your individual deployment of these apps. There's actually two sides to this. So yeah, it simplifies the process of deploying serverless applications for developers, but as a developer you can also publish into the repository. Okay, so if you have an application that you've built that you want to share with other users, other customers, you can upload that into the serverless application repository and make it available for other users to access and for other users to deploy. There might be other users within your organization, there might be other users in the public sense in the broader serverless community, broader community of AWS users. Okay. At the moment there's no monetization directly within serverless application repo, so we're talking about kind of altruistic sharing of applications via this model, but you can have APIs that are called within your deployed code. Okay, and you can monetize those API boundaries that you define. You can actually use our AWS marketplace to do billing and monetization of those APIs if you want to do so. So if you did want to use this as a mechanism for building a business model where you're distributing a serverless, in quotes, SDK for access to a product that you've built, to an API endpoint that you've built, you can do that by using an API boundary as the monetization point. If you've ever experimented, has anyone here done any significant work with the Alexa, with Amazon Echo, and with the Alexa Skills Kit? Okay, one or two people. You'll know this is the same model. So you can't directly monetize within the Alexa Skills Store today, but you can build Alexa skills that require account linking. That account linking can be to an API boundary, and you can monetize at the API boundary. It's quite a similar model to that actually with the serverless application repo. You can monetize at the API boundary where your serverless application model applications interface with other resources that you operate as a service. Okay, so there are ways in which you can build businesses around this as well. This is in preview at the moment, and of course if you're not familiar with these excuse me, AWS terms, public preview means that essentially you have to request access to a service. We essentially gate and whitelist customers for access to the service based on their use case criteria. And if you do try to access SAM today, you'll see a request access to the preview form appear inside the console or on the website. enter some details about your use case there. Our team will evaluate your request and permit you access to the preview if you meet qualifying criteria. If you want to kind of shortcut that process, quick tip, you can access the previews via our developer advocates and evangelism team as well. So if there's something specific that you want to do that requires access to the preview, chat to myself, chat to Danilo, chat to Adrian, chat to another member of the team that's here today, give us some details and we can get you pushed through the process a little bit more quickly. We can help with that. Okay, so that's a little bit about the serverless application repo. I did say that I'd return to editing in the console. This is something that we've enhanced a lot recently. About 18 months ago, we acquired a company called Cloud9. Okay, this is a company headquartered in the Netherlands with a mostly Dutch engineering team, who had built a browser-based IDE. Okay, so a development environment that runs entirely within the browser. And it's actually one feature about it that I really like. If you've used something like Google Docs or Quip, you'll know that they have concurrent editing. So it's not like a traditional version control system where you're checking out assets from a repo, working on them and then checking them back in again. And you've got a sort of async working model where I do something and then you do something and then you do something and then I do something, which kind of lengthens the process. With these modern collaborative editors, we're in the same document at the same time, right? I can see which cell in your Google Sheet you're in, and you can see where I am in my Quip document that we might be collaboratively editing on. Cloud9 does the same thing, but for code. So we can both be collaborating in the same file, in the same code base concurrently. We can both see where each other's cursor is in real time. Okay. And there's integrated chat features available in the client as well. So we can not only write in the code base, but we can also type and cut and paste in an interactive chat box, which is adjacent to the code base in the GUI. It's kind of nice. It's like a distributed pair programming tool where you can work concurrently on the same code base, see each other's changes in real time. And it's really helpful for writing accurate, correct code without having to have this sort of long asynchronous code review model where I do something, you validate it, and then pass it back to me, which I actually really like. I think I've never seen anything like that before applied to this particular kind of use case. I think it's pretty cool. So this AWS Cloud9 is now available as a standalone service, and there's quite a lot of integration with other AWS services. Probably going to talk about CodeStar a little bit later on in the course of some of the sessions that we're going to have, which is our end-to-end continuous integration environment, which allows you to really simply establish source code control, build pipelines, deployment tools, application metrics. Okay, so that's AWS CodeStar. Cloud9 is also integrated with that, so you can create a project in CodeStar and create your Cloud9 IDE environment directly from within the CodeStar tooling, and end up with not only with those resources that I've talked about, but also with an IDE environment for you to develop your code, provisioned as part of the process. So it's integrated there. The other place that it's integrated is in the Lambda console. So if I jump into the Lambda console and go edit function today, I don't just have a box within which I can change my function code. I have a complete Cloud9 IDE embedded within the Lambda console. So I can not only edit my function code, but I can also see all of the dependencies within my package that I've deployed. They're all available to me to inspect. You can see the hierarchy of my deployment archive available to me. Of course, I can modify my code, and it has syntax checking, linting. It has the ability to spawn an AWS terminal session with our command line tools directly within the editor. So you can run AWS CLI commands. It has the ability to step through and debug JavaScript code natively, insert breakpoints, halt execution, inspect variables and program state directly within the editor. So you have a fully fledged IDE that is embedded directly within the AWS Lambda console, supports editing for all function types and these advanced debugging operations for JavaScript today, with additional support for additional languages to come in the future. Okay, so really nice enhancement. Okay. What else have we done which is new? A lot of these could be regarded as developer experience tweaks, feature tweaks, which are intended to broaden the applicable use cases for AWS Lambda and make it suitable for more use cases. And one thing you should know, probably some of you know this already, AWS product development, the service development that we do, well over 90% of the enhancements that we create, the service features that we build, come directly from customer feedback. Okay, so pretty much every time we build anything, it's because we've had a conversation with more than one customer that said, I want you to change the way this works, or build this additional feature, or it might go, I can't use this particular service for this particular use case because of it's got this deficiency, it doesn't support this particular scenario that I have in mind. Okay, we work backwards from that to create new features. And what you're going to see here is a list of examples of situations where we've had feedback from customers that have helped us identify which direction we should take the development of Lambda and some of these associated services so that it fits a broader range of different use cases. Okay, so the first is on concurrency. It used to be 100 concurrent function executions per account per region. Okay, when we started with AWS Lambda, we increased that to 1,000 now. So every customer can run 1,000 concurrent Lambda functions per region by default. Okay, but if you make a limit raise request via our limits console, every account can be automatically approved to 3 times that without manual approval, manual intervention, as long as the account is, we call it, in good standing, which means your account is not an account with history of non-payment of bills or with behavior which indicates potential fraudulent usage. Okay, so like an account which has not been fully validated or verified. Okay, so as long as your account is in good standing, kind of reminds me of World of Warcraft that you've got positive reputation with the AWS faction. Some of you will get that joke. You've been grinding whatever those things are that we need to gain that. Then you can automatically get approval to 3 times the default. I mean, customers might ask, why do these limits exist? Okay, one of the reasons these limits exist is not so much to protect AWS, but to protect customers from overruns. This is a service where functions are triggered by events, yeah, and functions can be recursive in nature. One function can trigger another function. You can even, with things like step functions, have one function triggering 10 parallel executions of a function. So you could quickly have fan out, and if you make mistakes in your programming, you can quickly have excessive fan out. And if we didn't have these limits, you could run up actually quite large bills very quickly. So one of the reasons these limits are here is to enable customers to gradually dial up the amount of usage that they have, and to do that in a controlled way to control expenditure. Okay, I know of a customer in the UK, this is several years ago now, they had their limit set to 125,000 concurrent. Okay, so it was, at the time, 12,500 times the default limit, because the default limit back then was 100, and that was fine. So you can run these numbers up to very high levels if you've got a valid use case for that, and you can confirm to us that you definitely need to do so, and therefore you're happy to pay the costs associated with running functions with high concurrency. That particular example was for real-time push notifications for a gaming use case, where they were using the Lambda functions to modify the outbound messages that were going out to their mobile phone app, to their mobile app that they were running. So they were sending hundreds of thousands of these push notifications a second at certain times of the days and week. They were driven by events in the real world. They would send out many hundreds of thousands of these notifications, and every single one was personalized for a particular user with user-related metadata in the message that went out. So they were using Lambda in that way. Really high volume, really good use case, extremely elastic, because for the other 7 days and 23 hours and 40 minutes of the week, they had almost no activity on that service. So really efficient way to do it. And you can get to very high numbers if you need them, but 1,000 concurrent functions per account, per region, and auto approval to 3 times that. The second thing that we've optimized is cold start optimization. This is a sort of natural characteristic of the platform. What do you think happens under the covers when you first launch a Lambda function? So the first time we get a qualifying event, if we haven't run the function for a while, it's not on our infrastructure, so we would call that a cold start. It's on our infrastructure in the sense that the code package is in our infrastructure somewhere, but there isn't a cached copy of that code package packaged up in a container available adjacent to a CPU to execute. So we have to get the package, grab the container that the package is packaged within, pull it down onto a machine and execute it. and that's the cold start time that you have when you first run a copy of the function. Now that function will then be cached in the execution environment, and the second and subsequent executions, well, they'll be fast because the function code will be cached on the machine and they'll be available. There comes a point where you need a second copy of the function because you're exceeding the execution capacity of that first machine that you're running up. Probably going to put this in a second availability zone for durability and availability, but we have to get that container as well and pull that down, okay? And you'll have a second cold start somewhere in your list of executions when we get that second container and move it down to that second machine, and then a third and a fourth. Each time you warm up a new machine to start running a copy of the function on there, we're going to pull down the container onto that machine and run it. And because the containers come across the network, the bigger the function, the longer it takes us to pull the code down onto this machine and start to execute. It was a problem, particularly for large functions that had lots of dependencies bundled within them. Maybe Java-based functions were more susceptible to this because you quite often have very large class files that are dependencies that are bundled within the function. Even large post-compilation, so large bytecode files that are bundled up within the deployment package. We've made some optimizations here to drive down cold start. Okay, so gaining an up to 80% reduction in start times for larger functions. That's with positioning the code base differently and performing some other optimization steps as well inside the platform. Okay, so that can help you with overcoming latency at first start of a new copy of your function. Third thing is monitoring enhancements. So you can now see directly within the console, within your monitoring tab. I'm sure Danilo will show you this a little bit later on when he talks about developer experience in the console. You can now see your logs more easily, access your logging data more easily without the need to navigate between multiple AWS consoles, or with simplified navigation between different consoles, actually, is probably a better way to describe that. So that's like a DX experience to make it easier for you to debug and establish how your functions are behaving. Don't mention it explicitly within this deck, but we've also got integration with another service called AWS X-Ray. Anyone heard of that? I really like that service. It allows you to embed a special purpose SDK within your Lambda runtime, and that special purpose SDK instruments remote calls. So when you call out of the function to another AWS service, say Dynamo or Comprehend, I have instrumented in one of mine, which is a beta service for NLP, for natural language processing. You can see latency to these remote endpoints. You can also create custom instrumentation within your apps. So before I had Comprehend, I had a third-party sentiment API in one of my apps. I had custom instrumentation wrapped around that, so I could see the latency for me to call out to this third-party API endpoint and have my responses returned back to me. You can see all this in textual format in the form of what we call tracers, which are individual log entries for each function invocation. That includes a chart-based breakdown of execution time, where the different third-party components will be graphed out for you in linear format. It also includes service mapping. Okay, so that again is integrated directly within the Lambda console. You can see the tracers for a specific Lambda function, just click off onto them, as well as this textual logging. And then we also have increased the maximum size of Lambda functions from 1.5 gigs to 3 gigs. And this is actually really important, okay? And I think something that really needs to be reiterated to every new user of the platform. When we talk about memory, we're talking about all system resources being scaled in accordance with the amount of RAM that you allocate. So when you move that RAM slider up, what you're doing is allocating more of the host to the function. It's not actually just memory, it's also more of the CPU, and it's also more of the network throughput for that particular function as well. So you're allocating all resources in a manner which is proportional to the memory allocation that you make. If I give 1 gig rather than 100 megs, I'm giving 10 times the amount of CPU shares and 10 times the amount of network bandwidth to that function as well. Okay, so I shouldn't just think about my function may not be memory constrained, you know, it may be throughput constrained or CPU constrained, but I still move the memory slider in order to allocate more of those resources. Slightly counterintuitive, but it's just the simplest way. Okay, so everything scales. You can go from 100 megs to 30x that now to 3 gigs per function, and that will give you a whole substrate, a whole machine essentially, a full allocation of the resources on one machine. So the second time you start a function, it'll be running on a new machine. So you'll have more frequent cold starts with bigger functions. It's also something just to bear in mind. Okay. And then brand new, just in the last, what's that? Not quite a week ago, we announced general availability for 2 new runtimes. Okay, so we already have Java, Python, JavaScript, and we had C#, .NET Core 1.0 available. Those are the 4 runtimes. Now we have general availability on .NET Core 2.0, and we also have general availability on Golang as well. So you can write your Lambda functions in these. Directly within CodeStar immediately at launch as well. In fact, Paul Maddox, who's speaking here later on today, is responsible for some of these features. He actually built them. So if you want to ask more about that, he's a really, really good person to talk to. Obviously, Golang, very, very popular for microservices and web services development, and fully supported in Lambda as a first-class function from first-class citizen from last week. Okay, those are brand new. Okay, what's next? Yeah, so changes. Okay, this is one of the areas where we're getting quite a lot of feedback. We need more support in making AWS Lambda production ready. Okay, and in making the service production ready, we're thinking about all of the things which hang around the technology in order to make it easier for us to maintain and deploy applications using this model in a predictable way. So supporting rollback, roll forward, version control, testing, fitting within CI/CD pipelines, enabling us to do things like deployment control for canary deployments or weighted deployments where we might have A/B testing and the like. Okay, so it's kind of bringing some of the higher value control features that fit around software development processes and applying them to AWS Lambda in the way that we might apply them to other technology approaches. For real high-scale production use, these are important things. Okay, so going beyond simply having AWS Cloud9 inside the Lambda console, obviously we also have the standalone service, the standalone Cloud9 service. There's some advanced features in this which I did talk about a little bit later. What I didn't talk about earlier was something called SAM Local. So SAM Local allows you to establish independent development environments that contain the resource types that are defined within a SAM template. And those, as I mentioned earlier, were Lambda functions, API gateway endpoints, and these more simple DynamoDB tables. Okay, and when I talk about local instances of those services, I mean standalone copies of the Lambda runtime environment, of the API gateway endpoints, and of those simple DynamoDB tables that run locally independent of an AWS region. Okay, and now that local execution can be on your laptop, or it can be directly within the Cloud9 environment. If in the Cloud9 environment, of course, it's still in an AWS region, but it's not going back to origin. It's not going back to an actual Lambda function running on our execution environment. It's not going back to an actual API gateway endpoint running on our global infrastructure, and it's not going back to DynamoDB running on a table. So A, you don't have to provision those resources within your regular AWS account. B, you don't have latency to those resources. They're immediately available directly in the execution environment where you're running your code. And C, you don't have costs. Okay, so I don't have to provision read-write throughput units on a DynamoDB table just for testing purposes. I can do all of those things locally using the SAM local environment. We'll hear a little bit more about this later during the course of the day. Danilo's definitely talking about this. But the way it works is a set of containers are established directly in the development environment, either on the laptop or in the IDE environment in this case. And those containers literally contain copies of Lambda runtime. They contain an emulator for DynamoDB and a copy of the API gateway endpoint infrastructure as well. So you can run all of that locally, directly on your laptop or inside the IDE. Changes are instant. You don't have any costs. You're not traversing the internet to reach our endpoints in an AWS region. Okay, it's also integrated within the Cloud9 IDE, so I can spin up a SAM local environment directly inside the machine which hosts my Cloud9 IDE, can benefit from all of those features adjacent to where my code is stored, back in the cloud in this case, but adjacent to where my code is stored directly on the local machine. So that's a pretty nice set of features. Okay, from within Cloud9 IDE, you can of course directly deploy to your Lambda service, so replacing existing functions natively from within the Cloud9 IDE, and we have version control as well, so you can talk to any Git compatible endpoint, our code commit service, GitHub, GitHub Enterprise, or Bitbucket or other Git compatible endpoints that you might run elsewhere. Okay, so you can both operate in the Cloud IDE and then check your code in, check it out, and work with it on a laptop if you're going to be operating disconnected. There aren't actually that many environments in which we operate disconnected today, unless, like me, you live in the UK and travel by train, in which case all bets are off. You need a local environment. Our broadband infrastructure is pretty dire. Wireless broadband infrastructure is pretty dire. Not endowed with great train Wi-Fi like you have over here in Sweden. Okay, so that's the idea. And then the build process. Okay, so we have something called AWS Code Pipeline, which literally what it says, it allows you to establish a pipeline to build and deploy software automatically. Using AWS CodeStar is no doubt the easiest way to get started with this. Okay, so you can create your application within CodeStar from a template, and it will establish the source code control and build pipeline for you. You can also snap in and snap out different components here. So a good example of that would be at the front end. You know, maybe I've got some projects that I want to do open source maintenance, open, have them integrated into the GitHub ecosystem. Well, I can replace code commit with GitHub. I can initiate my code pipeline on commit to a specific branch stored in GitHub rather than commit to a specific branch stored in our code commit service. Conversely, maybe I've got a high security requirement for my code base. I want to make sure that it's stored in a specific location in the world in order to meet compliance requirements. I want to make sure that I have multi-factor auth around my code. I want to make sure that I have all of the AWS compliance controls that are available. I want to make sure that my code base is stored extremely durably. If those are the criteria that I want to meet, then maybe GitHub isn't a good answer, and I want to have code commit because it meets this extremely high compliance bar that I know I can rely upon AWS to meet. So maybe I use code commit for that kind of project, but GitHub for some other stuff. So this is pluggable at the front end. And then in the pipeline, these are individual AWS services, which you probably recognize: Code Build, CloudFormation, CloudWatch. With CodeStar, we'll provision these services as resources within the pipeline, but I can then go in and modify them as standalone services using the regular tools that I use. So it'll establish the environment and then free to customize, modify, and evolve that environment over time. Okay, so I can change the way in which my pipeline works as my project gets more complex or as my business requirements change. That's it, really. Very, very easy to use, very, very powerful tool. Additional feedback we received. Oh, go back. Additional feedback we received. Sorry, get it back. I talked about some of this stuff already. So deployments. How can I introduce some of the advanced features that I might use today to enable me to do safe incremental deployment of applications, features that were historically not present inside AWS Lambda. We're doing a lot of work to make AWS Lambda more suitable for enterprise and production use cases. So some of the things that we've introduced: weighted aliases. Okay, so this allows me to do traffic shifting, proportional traffic shifting between multiple versions of the same function without having to do that at the API gateway using weighted DNS records. Is how I might have done it historically. So at the front end, I might have distributed all of my traffic across a DNS record and had 70-30 or 90-10 distribution across two different API endpoints. There's quite a lot of heavy lifting there, and also then there's a dependency upon all access to my function entering via that API endpoint and all access to my function using DNS resolution for load balancing. It's not practical. I do quite a lot of development on a service we've got called Amazon Lex, which is our service for chatbots. I'll be talking about it in the other track later, and you'll see quite a lot of Lambda usage there and quite a lot of Python code as well. There's no DNS resolution for for Lex to talk to Lambda. It's just natively invoking those functions inside the AWS platform. So that approach of using DNS for traffic distribution, well, it's just not available for that sort of use case. But with these weighted functions, it is. Okay, so I can have two versions of my Lambda function deployed, and I can balance traffic across them. It doesn't matter what the invocation source is, whether the invocation source is an API gateway invocation source, a Lex invocation source, a Kinesis stream, whatever it is, I'll be getting both functions invoked in whatever proportions that I specify. I can instrument them and use them for A/B testing. Okay. If you are using the API gateway, we've got substages in the API gateway allowing you to share traffic between two stages at the front end. So again, there's no need to use weighted DNS-based distribution across two different API gateway endpoints. You can balance across different stages within the same API gateway endpoint, much simpler to manage at the front end. Okay, and then lastly, with code deploy, we have automated support for safe services deployment, which means automated metrics-driven rollout and rollback. So if I deploy a function and I see elevated error rates as a result of deploying that new version, I can automatically roll back to a previous version of the function. That's a really nice feature. If I break something, I can revert back to a prior version which didn't exhibit those issues and be functioning again without having to issue a command or have a member of my ops team diagnose that issue. It's all automated. Really nice feature. Okay, how does this look? So in the console, you can specify weights. Okay, this is actually in deployment where we're looking at deployment status, pre-deployment validation. Step 2 is traffic shifting to the new function, post-deployment validation, and then we'll roll through. And this is what the console looks like as we're in this traffic shifting phase. So we've done our validation. Essentially, we've got a working deployable. Okay, then we start to move traffic. You can see over here in real time how our traffic is being distributed. So here we've got 90% of the existing version, 10% of traffic on the new. As we move through the process, that will shift. Okay, so a more substantial amount of traffic is being shifted over now as this deployment is in process, and 40% of our traffic is on our new variant, 50-50. And eventually we complete our deployment process. You can see all this in real time in the console as code deploy pushes out that new version of your function. You can also do these canary deployments. So this is putting a new variant of a function into production, of course, with just a limited subset of users or a limited subset of invocations hitting that new variant. Okay, and this is where our automated rollback and additional instrumentation within our function could be valuable. Okay, so of course there's more here than just are we getting error codes returned by our function. There's also the question of whether or not the new variant of our function actually helps us achieve the business objectives that we want. Okay, maybe there's a change that we've implemented to improve performance and reduce latency. So we could instrument for that and evaluate that over those 10% of new function invocations, establishing whether that code is actually more optimal than the previous version that we had. We can control that canary deployment manually, promoting it to a production variant. We can also see directly within the console how many copies of our canary getting invoked in comparison to copies of our original function. Here we've set 90 as our ratio, so 90% traffic goes to our prior version, 10% new, and you can validate that within the console. We've got 1.12k hitting prod and 113 invocations hitting our canary over the same period of time, which just illustrates that 90-10 ratio that I've talked about. That's visible directly within CloudWatch. Okay, so now we're talking about, I'll do this pretty quickly because we're out of time. Now we're talking about enterprise features. So a lot of what I've talked about is high value for application developers that are using modern tooling, very familiar and comfortable with CI/CD approaches, want to have a really high degree of automation in their deployment workflows, and want to strive towards having, amount of operations overhead, essentially. Things like automated rollback in the event of error. That really allows my developers to be more autonomous and to use tools to defend themselves from issues, right? Rather than having an ops team that are taking the blame, the developers can roll back in the event that functions don't perform as expected. The other side of this is features that are intended for enterprise users. And there's another category of stuff here that we can quickly talk about. So dealing with legacy things. Things you might want to do: monitor concurrency, limit concurrency, hook up APIs to VPC-based services, and audit and log function invocations. Okay, and there's a few reasons that these are important, again, based on customer feedback. So, I mentioned before that I would talk a little bit about valid reasons that you might want to limit function concurrency. There's a couple of reasons for that. One of them is my backend systems might just not have the capacity to deal with the level of traffic that I'm seeing in a new service that I release. You know, if I'm a legacy organization and I'm experimenting with opening up mobile first channels for my customers to interact with my product or with my service or with my organization more generally, what sort of risks does that present? How do I right size my legacy infrastructure for this experimental new channel? What if the experimental new channel is way more popular than I anticipated? That might degrade service quality for existing users. It might result in me breaching licensing obligations or terms that I have. What if I've got a database backend which is licensed for 100 concurrent connections, but I've got a mobile app which is heavily trafficked, which is driving 10,000 concurrent connections? How do I govern that? How do I control it? So concurrency control is really important to these kinds of use cases. And there's a few things we've added here. First of all, we've added a visibility feature, which is concurrency metrics. So I can see in the CloudWatch console how many copies of a specific function are running concurrently. Simple, but a valuable feature to enable me to assess of the base of functions that I have, how is that distributed across different functions that might comprise my app. What we had before this was that simple limit of 100 or 1,000, but you couldn't actually bucket that down and see that I had 59 copies of this one, 61 copies of this one, and 900 copies of this one running concurrently. It was just, you've hit your limit, and that was the only visibility that you had into the metric. So we've allowed you to see a level of detail below that. And moving beyond that, we've also now allowed you to establish concurrency limits per individual function. So each individual function that you've got defined, you can specify a concurrency limit independent of other functions that are running. So say I've got some functions that interact with one of these backend databases, I can pin that one to 100 concurrent executions and not apply a metric to any others, allowing them to consume the rest of my capacity in whatever ratio they want. Or maybe I've got a prod and test environment. I can have 95 connections for my prod environment, 5 for test, and leave the rest of them unconstrained. I can define my own policy essentially. It enables me to limit concurrency to legacy systems. It allows me to do this protection model as well. I just don't want to overwhelm the backend systems. That's also an important feature. I can use this to temporarily disable a function. So I've got a function I want to take out of service, set the concurrency to 0, and it will still be there in the account. I don't have to deprovision it, but I can just prevent it from getting executed. That's quite a useful feature as well. And then lastly, I can develop functions with runaway protection. If I do have functions that are recursive in nature, maybe I've seen issues where I've had overruns for whatever reason, not yet being able to diagnose precisely what's causing that. I can just put a backstop there to prevent those symptoms from occurring again whilst I work on the root cause and remove it. My application is still functional, but if I do have another occurrence where my code misbehaves and I start to overrun my cost base, I can constrain that. And then almost lastly, VPC private links and regional endpoints. So this is providing access for Lambda functions to resources that are within a VPC. Okay, now we've had VPC support for Lambda functions for quite a while. This is a useful feature for things like connecting Lambda functions to relational databases. Okay, relational databases typically relying on secrets for authentication rather than cryptographic signatures, so they're weaker than the authentication and authorization model for them is weaker than the authentication and authorization model for things like before. You've got shared secrets that are required for access to relational database endpoints. Because those secrets are difficult to automatically rotate, okay, you want to protect them. And this protection normally takes two forms. Storing the secrets in some kind of secret store where they're protected by encryption, of course, okay, and we have a feature for that inside Lambda, which I'll just touch upon briefly in a second. And then secondly, putting the database endpoints themselves somewhere where there are additional layers of protection around them. And those additional layers of protection are typically private subnets within VPCs, so they're on non-internet routable addresses, and then security groups that provide stateful traffic filtering for connections to and from those private endpoints that are within those private subnets. So in Lambda, there's a couple of things here that are relevant. The first is there is secrets handling within AWS Lambda. You can inject secrets into Lambda functions using environment variables. You can encrypt those environment variables using a service we have called KMS, which is the key management service that encrypts them with AES 256-bit encryption. And then there's an encryption helper that you can run within your Lambda function that will decrypt the environment variables at function startup time. This means that your environment variables only head into your Lambda function encrypted with AES 256-bit encryption, so they're encrypted in transit across our infrastructure, okay? And then secondly, you can audit access to the wrapper keys that are used to decrypt those environment variables within the function. So it's a very strong encryption environment with visibility of each decrypt operation available in audit. That's actually a really powerful feature. And anybody that's using secrets in Lambda should use that approach. It's so easy to do that you might as well just encrypt all of your environment variables and do that. Okay, so that's one thing. Then the second thing is, when you establish a Lambda function inside a VPC, it has a security group associated with it. Okay, so it uses the same access control mechanism as an EC2 instance. The database instances that you run inside your VPC can only be accessed by Lambda functions that have the right security group. So you have stateful traffic filtering for access to your database endpoints as well. So just like EC2 instances in that sense. Okay, this is actually slightly different. This is for bringing in other services to your VPC in a secure way that might run outside the VPC. And actually just this week, we announced a private link endpoint for KMS. So your key management service endpoints, the ones that are going to be used to decrypt, for example, your database secrets using these wrapper keys, they can actually be presented directly within your VPC. So the KMS endpoint that you communicate with to do your decrypt operations or to get your keys, that can be inside your VPC in a private subnet as well. So that traffic doesn't have to transit the public internet either. So there's lots of capability to bring in services. And actually, anybody can establish one of these VPC link endpoints. So you can create this in one AWS account, and then you can privately present it inside a VPC in a second AWS account using one of these VPC links, which is part of our programmable network platform, uses our network load balancer, and allows you to securely present endpoints inside VPCs between accounts. Actually a very powerful feature. Okay, so there are lots of steps forward that we've taken to help customers get their traffic off the internet. Okay, and the last thing to talk about is logging and auditing. So very important for enterprise customers that might have regulatory oversight. A couple of things we've done here. We've added structured logging for the API gateway, so you can see structured log messages for API gateway requests. And then secondly, we've added CloudTrail support for Lambda functions. So CloudTrail is our auditing service. If you're not familiar with this, it operates at the control plane within AWS. So each time I deploy a new Lambda function or invoke a Lambda function using our control plane endpoint, then we can have a CloudTrail audit log entry appear, okay, which we can subsequently use for verification, inspection, forensics, compliance reporting. One of the nice things about CloudTrail is you can store your CloudTrail logs in a different AWS account, okay, with different permissions, with a write-only policy. So you can use it for out-of-account logging and auditing. Really, really good for establishing a sort of bastion control point for all of your logging activity and keeping it outside of the blast of potential account compromise attacks. Okay, so for those customers that need the highest levels of compliance, that's a really, really important feature as well. Okay, so just recapping, things that we've focused on here in these enterprise use cases. It's really trying to make AWS Lambda and serverless approaches more generally more suitable for developers that are working in environments where most of the applications already exist. They need to integrate with AWS Lambda-based environments to help them take advantage of this new way of building apps. Or it's for customers that have to meet specific compliance requirements in order to operate in certain markets like regulated industries in payments, pharma, or the financial services, for example. Okay, so really trying to work to help make AWS Lambda more suitable for those use cases. Okay, so that concludes session 1, which is a quick update on what's new with AWS Lambda. I'm going to turn it over to Danilo.